All right, we're doing one more. Welcome back. It's chapter 7, lesson 4. We're doing ratios in fraction form. All right, so this means just recognizing and interpreting ratios that are given in the form of fractions and then writing ratios in the form of fractions in order to compare some quantities. This will make sense as we get rolling here. But I kind of gave you a heads up that it was coming too. All right, fella. Oh, that's what happens when you hold your board upside down and nothing goes where it's supposed to. All right. Yeah, that's a good spot for now. All right. Ratios can be written in the form of fractions. Here's Jason. He's got two colored pencils, one red and the other blue. The length of his red pencil to the length of his blue pencil is represented in the model. All right. So you can show it as the ratio 3 to 5 or as the fraction 3/5. Or his red pencil is 3/5 the length of the blue one. Okay. Or the blue pencil is 5/3 the length of the red. Blue is 5/3 of the red. Red is 3/5 of the blue. Or red is 3/8 of the total. Blue would be 5/8 of the total. Pause me, listen to that, reread it till it makes sense. All right. Let's compare Sam and Jean's height as represented by this model. Sam's height of 5 units to Jean's height of 6 is 5 to 6 or 5 to 6. Sam's to the total is 5 to 11 or 5/11. Got it? Not too bad yet. In this table, you're given the ratio of a quantity to another quantity. 3/8, 3/8, 4/7, 4/7, 5/9, 5/9. Okay. And what's any of that mean? Says the guy who never looks at his teacher's guide before doing this. Because I like to be in the moment with you. Oh, there's questions. There's questions. Oh, here's the chart again. Look at the fraction form of each ratio. Notice the quantity in the numerator. Look at the same quantity in the ratio. Where is its position? Front, top, front, top, front, top. Denominator, second, bottom, second, bottom, second, bottom. Okay? What can you say about the relationship between the ratio and the fraction form? The ratio is written in order from denominator to numerator, basically. Okay? You can write ratios in fraction form to find out how many times, what does that say? One number or quantity is as large as the other. So here are the adults and children watching a show. 4 units of adults and 12 units of children. How many times the number of children is the number of adults? Or how do the adults compare to the children? Well, there's 4 adults for every 12 children. So 4/12 or 1/3. The number of adults is 1/3 the times the number of the children. So this is where the language is just going to turn into a nightmare on us if we're not careful. Okay? How many times the number of adults is the number of children? So it's worded so obnoxiously, but you're going to say, all right, we have the children compared to the adults. What's the children compared to the adults? It's 3 to 1. Or the children, there are 3 times as many kids as there are adults. Okay? Reread all of that. It's as clear as mud, as they say. All righty. Felice and Brad. Amount of money Felice spent. How convenient. Amount of money Brad spent. 42. The amount Felice spent is 21 42nd times the amount of money Brad spent, or 1/2 times the amount of what Brad spent. Brad spent 42 to Felice's 21, or 2 to 1. The amount of money Brad spent is 2 times the amount of money that Felice spent. All right, pause and process if you need to. Steve and China. Okay, Steve saved 3/4 as much as China. Here's China's savings in 4 units. Here's Steve's as 3 units. In fraction form, Steve's savings to China's savings is 3/4, or 3 to 4. Okay, total number of units is 7. So the ratio of China's savings to Steve's is 4 to 3, or 4/3, and the ratio of China's to the total is 4 to 7, or 4/7. Okay? Be very careful about the order these things are written in. Okay. Ryan cut a rope into 2 pieces. The length of the first piece was 4/7 the length of the second. The ratio of the length of the second piece to the length of the first piece is, well, here's the second, it's 7 to the length of the first is 4, or 7/4. The ratio of the length of the second to the total is 7 to 11, or 7/11. Okay. If you read, it's mostly just counting, you guys. Oh, you can write your own fraction forms for these scenarios. Okay, that's your pairs or partner work. Okay, practice. The ratio of x to y is, well, hey, look how many x's there are. 2. How many y? There is 7, or 2/7. X is 2/7 times y, or y is 7/2 times x. Right? You like that? You like that? There you go. All right. The ratio of the length of pole A to the length of pole B is as represented. 4 to 5. Oh, here we go. I moved it down here. Smart me. Give the ratio of pole A's length to the total length in fraction form. Well, the length of pole A is 4. So the total would be 9. And in fraction form, that would be 4/9. How many times pole's A length is pole B's length? So watch how that's written. So they're really asking about pole B, how it compares to pole A. So pole B is 5 to A's 4, or 5/4. Then this is the opposite. How many times pole's B length is pole A's length? Well, pole A is 4/5 of B. You, sir, in the way. How many times pole A's length is the total length? Well, the total is 9 to 4. And the total compared to pole B is 9 to 5. Reread these again. And it seems counterintuitive because it's coming at the end, but this is what they're focused on in each problem, is that bit. Okay, so that's kind of your foundation that you're working with. Okay. Last page, cool. Pause me, and I'll pause me and do them all, and then I'll come in 5 seconds and tie this stuff up for you. Okay, carry on. All right, I thought about just looking it up, but that's kind of lame. Number 9, amount of money Jesse has, the amount of money Kimberly has. Oh boy. 15 to 21 in fraction form also equals 5/7. Does it give me 5/7? It does. How many times the money Kimberly has is the amount Jesse has? So that is also the way it's worded, 15 over 21, or 5/7. Because it's asking about Jesse's money, which is 5/7 what Kimberly has. How many times the amount of Jesse has is the amount of money Kimberly has? Well, Kimberly to Jesse is 7 to 5. Clear as mud, right, folks? How many times the total amount of money they have together is the amount Jesse has? So what part of the total does Jesse have? 5. If there's 5 units and 7 units, there's 12 units altogether. And then how many times the amount of money Kimberly has is the total amount of money they have together? There are 12 units of total money compared to 7 units of Kimberly's. The wording is way harder than the actual numbers on any of this. That's the kicker. Okay. Hey, we finished another one. Rock and roll. You have probably these workbook pages and this problem of the lesson. Pizza. When you're done, submit anything your teacher asks you to in the form that they request. Do some IXL practice. And as always, we'll catch you in the mañana, or Monday, or next time you're sick, or never. Whatever works. All right, bye, friends.